We now discuss the solution of a problem from the section Integral Calculus, and the problem is on definite integral. This question has appeared in the joint entrance examination main held on 24th June 2022 in the session 1. The problem is, let f of theta is equal to sine theta plus the definite integral minus pi by 2 to plus pi by 2 in brackets sine theta plus t cos theta f of t dt. Then the value of the modulus of integral 0 to pi by 2 f of theta d theta is a function f of theta is given to us, and which involves a definite integral minus pi by 2 plus pi by 2, but the integration is with respect to t, and for this f of theta we have to calculate modulus absolute value of integral 0 to pi by 2 f of theta d theta. So we have to find what is exactly f of theta after this integration is over, and then we have to compute this. So let's now discuss the solution of this problem in detail. Given f of theta is equal to sine theta plus the definite integral minus pi by 2 plus pi by 2 in brackets sine theta plus t cos theta into f of t dt. Now separate them. So the integral of the sum is equal to sum of their integrals. We'll get sine theta plus integral minus pi by 2 to plus pi by 2 sine theta f t dt plus integral minus pi by 2 plus pi by 2 into cos theta into t into f of t dt. Note down, the integration is with respect to t, not with respect to theta. Now sine theta comes out because the integration is with respect to t, it can come out. So that is equal to sine theta plus in brackets integral minus pi by 2 plus pi by 2 f of t dt sine theta comes out, plus so also cos theta in this also comes out, integral minus pi by 2 plus pi by 2 t f t dt cos theta. Agreed. And now sine theta is here, sine theta is here, sine theta you can take common, and that will be equal to in brackets 1 plus integral minus pi by 2 plus pi by 2 f of t dt sine theta comes out as a constant, plus integral minus pi by 2 plus pi by 2 t f of t dt with respect to t multiplied by cos theta. And let's call this as the a, and note down after this definite integral, so this comes out as a constant. So this whole thing is a constant. Let's call it as a, and this also a constant. Let's call it as b. So a sine theta plus b cos theta, where a is this one, 1 plus integral minus pi by 2 plus pi by 2 f of t dt, and capital B is equal to minus pi by 2 plus pi by 2 t f t dt. And thus we have f of theta is equal to a sine theta plus b cos theta, where a and b as given above. We continue in the next slide. We have f of theta, a sine theta plus b cos theta, where a is given by this and b is given by this. Now I will now evaluate what is this a. Now a is equal to 1 plus integral minus pi by 2 plus pi by 2 f of t dt. F of theta is a sine theta plus b cos theta. Therefore f of t will be a sine t plus b cos t. Substitute. So it is 1 plus integral minus pi by 2 plus pi by 2. F t is a sine t plus b cos t. Now integrate with respect to t. Now the integral of the sum is equal to sum of their integrals, and a is a constant as we have already talked about, and that will be 1 plus a into integral minus pi by 2 plus pi by 2 sine t dt plus b, because it's a constant, integral minus pi by 2 plus pi by 2 cos t dt. Now, sine t is an odd function. Is an odd function. Therefore, there is no contribution. It will be 0 integral. And cos t is an even function. Therefore, it will be written as 2 times 0 to pi by 2 cos t dt. So, that will be 1 plus, this is 0, plus 2 times b into integral 0 to pi by 2 cos t dt. Now, integral 0 to pi by 2 cos t dt will be integral 0 to pi by 2, and when you integrate cos t, you will get sin t. Sin t, when evaluated between the limits 0 to pi by 2, you will get the answer 1. So, that will be equal to 1 plus 2b. And why? Because the integral, since the integral 0 to pi by 2 cos t dt is after integration sin t, and to be evaluated from 0 to pi by 2. So, when after evaluation sin pi by 2 is 1, sin 0 is 0. So, you will get this one. So, this integral is the answer 1. So, 1 plus 2b into 1 is 2b. So, thus you have a is equal to 1 plus 2b. This is one relation between a and b we have obtained. So, let us now go for b in the next slide. So, f of theta is there, a we have already evaluated, and b is here. Now, b is equal to integral minus pi by 2 plus pi by 2 t times f of t. So, f of t is a sin t plus b sin t, substitute. So, that will be minus pi by 2 to plus pi by 2 integral t into a sin t plus b cos t dt. Now, a is a constant, comes out. Integral minus pi by 2 plus pi by 2 t sin t dt plus b comes out, integral minus pi by 2 plus pi by 2 t cos t dt. Now, sin t is odd, t is odd, product is even. Product is even. Therefore, it will be 2 times integral 0 to pi by 2. And cos is even, t is odd, the product is odd. So, integral minus pi by plus pi by 2, an odd function, will be 0. So, that will be equal to 2 times a 0 to pi by 2 t sin t dt plus this is 0. Because since t sin t is an even function and t cos t is an odd function, this happens. Wonderful. Now, we have to integrate 0 to pi by 2 t sin t dt. Let us see here in the box. Integral 0 to pi by 2 t sin t dt. We have applied the integration by parts. Then you will get t into integral of sin t is minus cos t to be evaluated between 0 to pi by 2 minus integral of the derivative of t 1, integral of sin t minus cos t. So, minus into minus plus, and integral of cos t is sin t. Sin t is to be evaluated 0 to pi by 2. And here t cos t, when evaluated between 0 to pi by 2, it will give the answer 0, and the answer is 1. So, the integral 0 to pi by 2 t sin t dt is 1. So, this is 1. So, you will get 2a. So, thus you got a relation that b is equal to 2a. This is the second relation. We have already obtained a relation between a and b in the last slide. So, let us look at these. Yes, a is equal to 1 plus 2b, that is our first relation. B is equal to 2a, that is our second relation. And now, b is equal to 2a, substitute in the first relation. Then you will get a is equal to 1 plus 4a, right? So, that will give you 3a is equal to minus 1, right? And that will imply a is equal to minus 1 by 3. When a is minus 1 by 3, b is equal to 2a, that is minus 2 by 3. So, the values of a and b we have obtained, and thus we know what is f of theta. F of theta is a sin theta plus b cos theta. A is minus 1 by 3 sin theta plus b is minus 2 by 3 cos theta. Now, this is to be obtained. So, modulus of integral 0 to pi by 2 f of theta d theta. That is equal to modulus of integral 0 to pi by 2 f of theta. F of theta is minus 1 by 3 sin theta minus 2 by 3 cos theta with respect to theta in the modulus. Integration is very simple, so let's do it. And that is modulus of 1 by 3 into integral of sine is minus cos, there is already a minus, therefore cos theta minus 2/3 integral of cos theta is sin theta, and this is to be evaluated between 0 to pi by 2, and modulus of 1/3 into, for the upper limit, cos pi by 2 is 0, minus for the lower limit cos 0 is 1, minus 2 by 3 into sine for the upper limit pi by 2 is 1, minus sine for the lower limit 0, sine 0 is 0. So you will get minus 1/3 minus 2/3, that is minus 1. So modulus of minus 1. So the modulus of minus 1 is plus 1. Therefore, the integral 0 to pi by 2 f of theta d theta is equal to 1. That's our answer. So that is the discussion of the solution of the problem from the section integral calculus, and the problem is based on the evaluation of definite integrals. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.